In this videotape, we will go over multiplication and division of polynomials. If you would like to see a more detailed treatment of this topic, I would suggest you look at the appropriate elementary algebra tapes. Here we're going to be going a little more quickly. Okay, let's start very simply multiplying monomials. That is, one-term polynomials are going to be multiplied. 3x squared times 2x cubed times minus 4x. Okay, what we're doing here, whether or not you write this step down, is to really rearrange the terms so that first we're handling the constant coefficients and then we're worrying about the variables. In other words, we're multiplying 3 times 2 times minus 4 times x squared times x cubed times x. Okay, 3 times 2, that's 6, times minus 4 plus 6 times minus 4 gives us minus 24. Now, here we're multiplying x squared times x cubed times x to the first. Okay? And since they all have the same bases, what we're going to do is add the power. So it'll be x to the 2 plus 3 plus 1, or minus 24 x to the 6th for your final answer. And of course, there's nothing wrong with going from this step all the way to the answer. Okay, but basically, your mind should be rearranging the terms so that the constant parts come first and then the variable parts. Okay, now this is the simplest type of multiplication because what we're multiplying are monomials. Okay, this is one term times one term. Now, the next order of difficulty would be if we had a monomial, say minus 5x cubed, being multiplied by a polynomial, x squared minus 4x minus 3, polynomial of more than one term. Okay, here we're going to be using the distributive law. Okay, just monomials, we just rearrange the terms and we handle it that way. But one term times many, we do it by the distributive law. We distribute the minus 5x cubed through the parentheses. So we get, and once again, this step is also a mental step, minus 5x cubed x squared, then minus 5x cubed times minus 4x, and minus 5x cubed times minus 3. Minus 5x cubed will be multiplied by the x squared, then by the minus 4x, and last by the minus 3. Okay? Now, each of these, of course, is multiplying two monomials, which we already know how to handle. So this first one gives us minus 5x to the 5th power. We're adding the powers here. Minus 5x cubed times minus 4x, we rearrange it, so we have minus 5 times minus 4, which is plus 20. X cubed times x to the first, that's x to the 4th. So plus 20x to the 4th. Minus 5x cubed times minus 3, that's plus 15x cubed. Okay, once again, you can go from here to here in your head. If you're having trouble, you can actually write it down. The most important thing is to remember that the minus 5x cubed must be distributed throughout the parentheses, okay, including these two terms. These are the most often forgotten. Okay, we've handled monomials by monomials, a monomial by a polynomial. Now, polynomials by polynomials. Okay, let's try, for example, 2x squared minus x plus 3 times 3x minus 2. You can think of this as, say, a times b plus c. Consider this entire first part, say, as a. And we're going to distribute it using a times b plus c is ab plus ac. We're going to extend the a through the parentheses. In this case, we're going to send the 2x squared minus x plus 3 through the parentheses. Okay, this will give us 2x squared minus x plus 3 times 3x me just move it down a little bit so I can get it all on one line. 2x squared minus x plus 3 times 3x plus 2x squared minus x plus 3 times minus 2. In other words, I'm writing this as AB plus AC. A times B plus C. It's A times B, 2x squared minus x plus 3 times the 3x, plus A times C. The whole trick is to think of this entire first polynomial, okay, as one quantity, one group here, to be distributed through the parentheses. Okay, now we're going to once again use the distributive law going the reverse way. 3x is going to be distributed through the parentheses here. So we're going to have 2x squared times 3x minus x times 3x plus 3 times 3x. 2x squared times 3x minus x times 3x plus 3 times 3x. And here I will have, let me just add it up down here because I don't have any space, 2x squared times minus 2 minus x times minus 2 and 3 times minus 2. 2x squared times minus 2 minus x times minus 2, 3 times minus 2. Okay, so what we've done is broken this whole thing down into a lot of monomial times monomial multiplications. The first one gives us 6x cubed, then minus 3x squared plus 9x. Then we get minus 4x squared plus 2x minus 6. And we're going to try to combine the like terms. We notice we have all 6x cubed. There's nothing that combines with that. We have minus 3x squared and minus 4x squared, giving us minus 7x squared. Plus 9x plus 2x, that's plus 11x, and then minus 6 for our final answer. By the way, there happens to be another way of doing this. Some people prefer it, some people don't. I'll leave it up to you. I just want to show it to you. We consider this to be a horizontal treatment of the problem. Okay, making this A times B plus C, sending it across A times B plus A times C, writing it all along one horizontal line. Another way of handling this, you want to multiply 2x squared minus x plus 3 times 3x minus 2. Okay, we can write the multiplication in this form and sort of do like a long multiplication. First thing we can do is we can take this 3x and distribute it through the, remember we took the 3x and we distributed through the parentheses. What we're going to do is take 3x and multiply it by each term on top. 3x times 2x squared gives you 6x cubed. 3x times minus x gives you minus 3x squared. 3x times 3 gives you 9x. Okay, then now that you've finished with the 3x, the minus 2 is going to be multiplied by every term on top. Minus 2 times the 2x squared gives you minus 4x squared. Minus 2 times minus x gives you plus 2x. Minus 2 times 3, minus 6. Okay, when I wrote the second line, I put the x squared term under the x squared term. This sort of helps us when we're going to be adding, okay, at the end, because we have our like terms underneath each other. Okay, what I did is first multiply 3x by everything in the top row, then multiplied minus 2 by everything in the top row. And I tried, when I wrote down the two different lines, to line them up so the like terms are underneath each other. Then you add 6x cubed minus 7x squared plus 11x minus 6, which is, of course, the same answer that we got to the problem the last time we did it. The basic thing when you're multiplying polynomials is to make sure that every term in one polynomial is multiplied by every term in the Now, there is a special case of polynomial multiplication which is particularly simple to handle. It's when you have a binomial times a binomial. Let me give you an example. Special case of multiplication. You're multiplying a binomial, let's say 2x minus 5, times another binomial. Okay, x plus 4. The special case is for binomial times binomial. And it's only for that. You cannot use it any other time. You're multiplying two terms by two terms. Okay, we use the FOIL method. First, outer, inner, last. We multiply the first terms together, 2x and x. The first terms in the two parentheses. The outer terms, 4 and the 2x. The inner terms, the minus 5 and the x. And the last terms, the minus 5 and the 4. Giving us 2x squared plus 8x minus 5x minus 20, or 2x squared, combining these two terms, plus 3x minus 20. Two x squared plus 3x minus 20. Okay, now you can check this by using the long method, say, of multiplying polynomials, or treating this as a, and this is b plus c. You'll get exactly the same answer. What makes this particularly nice is that you can really do it in your head and sort of go all the way down to this step in your head. And it's important that we be able to multiply binomials because we're going to need this when we come to factoring later on, to be able to do this kind of multiplication very quickly in your head. Okay, first terms, 2x squared. The outer is 8x, the inner minus 5x, giving you the plus 3x, the last minus 20. Okay, on these, very often the outer and the inner. Okay, the kind of problems we'll be handling, very often the outer and the inner terms combine to just one term, so the answer has three terms. Okay, let's try some more examples. 5x minus 2 squared. Okay, some people have trouble with this. They somehow feel that they should be squaring this and squaring that. They forget that 5x minus 2 squared means 5x minus 2 times 5x minus 2. It's a binomial times a binomial, and it should be done by the FOIL method. Okay. The first terms give 5x times 5x, giving us 25x squared. The outer terms giving us minus 10x. The inner terms, minus 10x. And the last terms, minus 2 times minus 2 plus 4. Final answer of 25x squared minus 20x plus 4. When you're squaring a binomial, okay, it should be noted that the outer and the inner terms will always come out to be the same. So this will be twice the outer or inner term. Let's try one more multiplication. X minus 3 squared times x plus 2. This is x minus 3 times x plus 2. Well, first we use FOIL to multiply these two binomials. And we get first x squared. Outer is minus 3x. Inner is minus 3x. That's minus 6x. Last terms, minus 3 times minus 3, that's plus 9, times x plus 2. Okay, now since here we want to multiply a trinomial by a binomial, okay, we can't use FOIL anymore. We have to use either the horizontal or vertical treatment for the multiplication. If we use the horizontal treatment, we think of this whole thing, say, as a. And we want to multiply it by b plus c. So we're going to get ab plus ac. That is x squared minus 6x plus 9 times x plus x squared minus 6x plus 9 times 2. Okay, now we distribute the x through this parentheses and the 2 through that one. X times x squared, that's x cubed. X times minus 6x, that's minus 6x squared. X times the 9 for 9x. And now distributing the 2 through the second parentheses here, we have 2x squared, 2 times the x squared, 2 times the minus 6x for minus 12x, 2 times the 9 for 18. Now combining like terms, we have x cubed, no other x cubed terms. For x squared, we have the minus 6x squared and the plus 2x squared, giving us minus 4x squared. Then we have a plus 9x and a minus 12x for minus 3x, and the plus 18. X cubed minus 4x squared minus 3x plus 18. Okay, now let's take care of some division problems. Let's start with a polynomial divided by a monomial. Okay, this is done a special way when you have division by a monomial. Let's say we have 8x to the 5th minus 6x cubed plus 10x squared. 8x to the 5th minus 6x cubed plus 10x squared, all divided by 2x squared. Division by a monomial. A monomial. One term. This is handled in a special way. First of all, what you do not do is start canceling out 2 into 8 and x squared into x to the 5th or something like that. That's out of the question. Okay? What you can do is break it up and put each term in the numerator here over the same denominator. We can write this as 8x to the 5th over 2x squared, and then minus 6x cubed over 2x squared, and then 10x squared over 2x squared. In other words, it breaks up into 3 parts, 3 little problems, each one of which can be done very easily. You take the first term in the numerator and divide by the monomial. The second term in the numerator, divide by the monomial, and the third term. Okay, what we're doing here is making use of the fact that, say, a plus b over c is a over c plus b over c. This is our rule. It comes from the distributive law. You can break up numerators. Okay, if you have 2 terms in the numerator, or 2 or more terms in the numerator over 1 term in the denominator, you break it up, put each term in the numerator over that common denominator. That's what we've done here. Now, within each of these terms, we can simplify. 2 into 8 goes 4 times. X squared into x to the 5th goes x cubed times, or you can say 4 x to the 5th over x squared is x to the 5 minus 2, subtracting the powers, giving you 4x cubed. Okay, you're dividing, they have the same base, you can subtract the exponents. Minus 6 over 2, that gives you minus 3. X cubed over x squared is x to the 3 minus 2, or x to the 1. And then finally 5. X squared over x squared, either the x squareds cancel out, or you could say x to the 2 minus 2, which is x to the 0 or 1. So 4x cubed minus 3x plus 5 for the answer to this problem. Okay, now this is done a special way because it was division by a monomial. Okay, if you're not dividing by a monomial, we're going to use a long division kind of process. For example, 3x plus x to the 4th minus 6x squared minus 8 over x minus 2. We want to divide. We're not dividing by a monomial. We're going to have to use long division. Okay, now, there are 2 things to remember when you're doing long division. First of all, you must rewrite your numerator so that the terms are arranged in descending order of degree. Okay, the term with the highest degree first, and then second, and so on. Okay, and secondly, you want to make sure that every term is accounted for. So I'm going to rewrite this as x to the fourth. Let's see. We don't have an x cubed term. I'm going to put one in, 0x cubed. Then minus 6x squared plus 3x minus 8 over x minus 2. X to the fourth plus 0x cubed minus 6x squared plus 3x minus 8, all divided by x minus 2. We've done two things. We have rearranged the order so that we go from highest degree term to lowest. Here's a fourth degree term, third, second, first. Okay. If there are any terms missing, I want you to put a placeholder. This is optional. Some people manage without it. I tend to think it makes it a little easier when we're working it out. So there was no x cubed term, but we did have an x to the fourth to start, so I'm going to put a 0x cubed. I don't have to put a 0x to the fifth. I start with this one, and then I want to make sure all terms beneath that in degree are handled. OK, now what we're going to do is a long division process. I'm going to pattern it after the long division that you've seen with arithmetic. For example, let's say we wanted to take 840 divided by 25. Okay, this means 25 into 840. So first we put 25. 25 doesn't go into 8. We look at 84. 25 into 84 goes 3 times. 3 times 25 gives us 75. We subtract 84, take away 75, and we get 9. Bring down the 0, and we go again. 25 into 90, once again, 3 times, 4 times would be 100, which is too large. 3 times 25, 75. We subtract, giving us a remainder of 15. We can write our answer as the quotient, 33, plus the remainder over the divisor. That is 33 plus 15 over 25. Okay, if you were to change this into 25ths and add this, you would get 840 over 25. We're going to do the same kind of thing when we're working with the algebraic long division as we did with the arithmetic long division. Okay, we're going to take x minus 2 into x to the fourth plus 0x cubed minus 6x squared plus 3x minus 8. Okay, we're going to start by saying, how many times does x go into x to the fourth? Goes in x cubed times. And we're going to then multiply. Now, here we have to multiply the x cubed times the x minus 2. You see over here, how many times does 25 go into 84? 3 times. We then multiply the 3 by the 25 to get 75. The same thing here. When we multiply x cubed times x minus 2, we have to distribute the x cubed. X cubed times x gives us x to the fourth. X cubed times minus 2 minus 2x cubed. It'll always work out that the first term here will be the same. The first terms will be the same. Otherwise, you've done it incorrectly. So when we subtract, we want this first term to drop out. That's why we asked ourselves, how many times does x go into x to the fourth? We put in the x cubed so that x cubed times x would give us the x to the fourth. Now we subtract. And bring down the next part. Now, when you subtract, you're going to change the signs and add. So you can do this explicitly or do it in your head. You can think of this as plus x to the fourth. We're going to change it to a minus. Minus 2x cubed, we're going to change it to a plus, and then we're going to add. The x to the fourth minus x to the fourth, that drops out. The 0x cubed and the 2x cubed gives us 2x cubed. and we bring down the next part, minus 6x squared. How many times does x go into 2x cubed? It goes in 2x squared times. We're asking ourselves, what do we need here so that when we multiply by x, we'll get 2x cubed? We now take the 2x squared times the x to give us 2x cubed. The 2x squared times the minus 2 is minus 4x squared. We're going to subtract. Okay, so we're going to change the signs. The plus I'll make a minus, the minus I'll make a plus. Change the signs and add. The 2x cubed and the minus 2x cubed, they drop out. The minus 6x squared and the plus 4x squared gives you minus 2x squared. Bring down the next part, which is the plus 3x. How many times does x go into minus 2x squared? It goes in minus 2x times. Minus 2x times the x gives us the minus 2x squared, but then also minus 2x times the minus 2 gives us plus 4x. Okay, we're going to subtract. We change the signs and add. The 2x squared and the minus 2x squared drop out. The 3x and the minus 4x gives us minus 1x, minus 8, now bringing down the last term. How many times does x go into minus x? The answer is minus 1. Minus 1 times x gives us minus 1x. Minus 1 times minus 2 gives us plus 2. We're going to finally subtract, change the signs, and add. The x's go, we get here a remainder of minus 10. Okay, so you can write this as x cubed plus 2x squared minus 2x minus 1 remainder 10, or going back to the original problem, you can write this as the quotient, x cubed plus 2x squared minus 2x minus 1 plus the remainder over the divisor. Okay, these two are algebraically equal. X cubed plus 2x squared minus 2x minus 1 plus the minus 10 over the x minus 2. You take the remainder and put it over the divisor. Okay, let's try one more long division problem, and that'll be the end of it for this tape. If you want to try this problem on your own, you can shut off the videotape machine after I give you the problem and tune it back on after you have worked it out. 8x cubed minus 8x squared minus 10x plus 6 over 4x minus 6. Okay, we already have it written in descending order of degree, and every term is accounted for, the x cubed, x squared, the x, and the constant term. So let's go. 4x minus 6 into 8x cubed minus 8x squared minus 10x plus 6. How many times does 4x go into 8x cubed? In other words, we're looking for something which when multiplied by 4x will give us the 8x cubed. So we need a 2x squared. 2x squared times 4x gives us 8x cubed. And then the 2x squared times the minus 6 gives us minus 12x squared. Which we subtract, we change the signs, and we add. The 8x cubes drop out. The minus 8x squared and the plus 12x squared gives us the 4x squared. Now bring down the minus 10x, the next term. How many times does 4x go into 4x squared? It goes x times 4x gives us 4x squared. X times minus 6 gives us minus 6x. We subtract by changing the signs and adding. The 4x squareds drop out. The minus 10x and the plus 6x gives us minus 4x. Bring down the last term, the plus 6. How many times does 4x go into minus 4x? The answer is minus 1. Minus 1 times 4x is minus 4x. Minus 1 times minus 6 is plus 6. We subtract, change the signs, and add. And when we do that, we get 0. No remainder in this problem. The answer is 2x squared plus x minus 1. And the remainder is 0. And that brings us to the end of the